discussed in the previous video to solve the questions of acid-base disorder. For that, I can assure that you will be able to solve almost all the questions that you can come across in your competitive exams for that. But then there are other methods as well, right? But I didn't discuss those methods in the previous videos, as that may had created some kind of confusion in your mind if I had discussed those methods simultaneously, and that may had made the video go longer, right? But then you need to know those things as well to strengthen your concepts, right? But then those things are not the something that you can solely rely upon to solve the questions completely. Those are discrete method. You can just check whether what you are doing is right or not, or you can guess the right answer to a maximum extent if you don't have time in your competitive exams, right? Like, one of those things I would like to tell is, if there is increase in the partial pressure of carbon dioxide by 10 unit, then there will be decrease in the pH value by 0.1, right? That's obvious. And if there is decrease in the partial pressure of carbon dioxide, then there will be increase in the pH value by 0.1. These are obvious things, but by observing if the changes are in this proportion or not, if the changes are not in these proportion, then you must suspect then there must be existing some other mixed problem. There's some other problem as well, right? That's a guess, you know. And if there is increase in the anion gap, then like if it has increased to 20 or 25, then it will be a case of metabolic acidosis for obvious reasons, right? And cause the substances that accumulate in the body in case of metabolic acidosis are negative charge, and that they replace chloride or bicarbonate, and then that in that way they increase the anion gap, right? And the other thing, if you don't want to apply the Rome rule, then you must know the other ways also. Like, if they have given you three values like pH and partial pressure of carbon dioxide and bicarbonate concentration, then you have to see which one of the two among the bicarbonate concentration and partial pressure of carbon dioxide explains uh, the the given pH value. If they have given that pH is acidic, and they have given that there is increase in the concentration of bicarbonate, and then there is increase in the partial pressure of carbon dioxide as well, which of these two explain this condition? The obvious reason will be the increase in the partial pressure of carbon dioxide, right? So it will be a respiratory problem. In the same way, if they have given their pH is acidic and both of those things are decreased, then for obvious reasons the decrease in the concentration of bicarbonate will explain this condition, right? So if you are not willing, or you find the Rome rule cumbersome, or you are not uh, feeling like doing those things, then you can apply this logic as well. So these are the things that you must know to solve the questions, in a fraction of seconds, in 10 to 15 seconds, to the difficult questions, as difficult questions as they can ask, right? Then there is one more important thing that I want to discuss here, is the grid method. That's very important and very useful method, but you cannot solely rely upon that method for the cases of mixed disorder all the time. But here it is, I am explaining it for you. You just have to draw two vertical lines, right, and two horizontal lines, right? I'm writing normal here. It is specific and is basic or alkali, whatever you want. It's simple as that. It's simple as that. don't be in hurry, just do it slowly, and you gradually will be able to absorb this concept, and then you will not require to draw it. It's a mental thing, but you need to absorb it, and for that I am drawing it here, right? If the acid base case is ABG is normal, then if we put the three values, that is pH and bicarbonate concentration and partial pressure of carbon dioxide, they will lie in this vertical line, in this mid column, right? In this mid column they will lie in this vertical line. This is the case of normal ABG. If it is compensated, right, they will lie in this horizontal line. Then you will ask how. Then I will say pH will be in the center, pH will be normal, pH will be normal, and one of the two things, partial pressure of carbon dioxide or concentration of bicarbonate, will lie in the opposite extremes. In the opposite extremes, right? One will be causing the problem, and the other will be trying to correct it, trying to compensate it, and it has somehow able to compensate it to bring the pH value in the normal limit, normal range, right? The normal range that is 7.35 to 7.45, right? The pH will is in this range, but the but the bicarbonate and the partial pressure of carbon dioxide lie in the two extremes. So if it is horizontal, it is fully compensated case, and if it is vertical, that is normal ABG, right? Then there is partially compensated cases, and there are mixed problems, right? So for partially compensated, the pH will not lie in this center, right? It will be acidic or it will be basic, right? So suppose if pH is here, right, we are left with two more data, that is bicarbonate concentration and partial pressure of carbon dioxide. One will lie here, one will lie here, one will lie here, and the other will lie here, right? In the opposite extremes. One will be causing the problem, and the other will be trying to compensate it or correct it, right? So they will be in the opposite extremes, but pH will be pH will be at the side of one data, and that data will be explaining the problem, right? If I write bicarbonate here, right, and pH here, that will explain that it is a case of metabolic acidosis, because the bicarbonate is in the acidic part and pH is in the acidic part, right? So in this way you can say that it is a case of partially compensated. In case of partially compensated, they will be in the opposite extremes, but pH will not lie in the center. pH will lie at one extreme, right? So the other thing is there can be a mixed problem as well, but for that I would like to tell you that you cannot solve all the questions of mixed problem with this grid. There is a grid method. It's a grid method. If pH lies at the one extreme and both the other remaining data lie in the same column, then both will be explaining the condition of the pH, and both will be the primary problem. Both will be both you know we will call them a mixed problem, right? A mixed problem. But you cannot solve all the questions of the mixed problem with this grid. Like if there is respiratory acidosis and respiratory acidosis and metabolic alkalosis, right, then you will not be able to solve the questions in this grid method. But if both are causing acidosis or both are causing alkalosis, then you will be able to solve the question by this method. And that's the reason I didn't explain this method in the first place. I explained the method that can solve that with which you can solve almost all the questions. But by knowing these things, you can strengthen those concepts, and you will be able to solve the questions in the minimum possible time in the competitive exams. And one thing is that one must know is that you are supposed to use your common sense in the competitive exams. They don't want you to just stick one thing, right? You have to create your own short methods, your short fundas supported